Hello, good evening, Aditi. Welcome to YouTuber. How are you?
I'm fine, sir.
Okay, good. So you have chosen for a chemistry class today. So today I'm going to explain you the stoichiometry. So what are the points that we are going to cover? So the first point we will see stoichiometry introduction, and then the next point that I'm going to cover is the important convergence in the stoichiometry. So you are familiar with this topic, Aditi, or just a little bit you know?
Yes, sir. I know a little bit.
Okay, don't worry. So I'm going to cover the detailed stoichiometry introduction and the problems. Okay, so let's try to understand stoichiometry by considering the cookies preparation. So you like the cookies?
Yes, sir. I like cookies.
Okay, good. Okay, let's say if you want to make the 10 cookies, then what are the ingredients we need? Obviously, we need a flour, that is, let's take it as 100 gram, then 2 eggs, then 100 grams of butter, and then the sugar. So adding all these ingredients, we are going to get the 10 cookies. Now, what is the important thing that you are going to focus here is the proportion. Proportion of what? Ingredient 1, ingredient 2, ingredient 3, ingredient 4. So this ratio or the proportion is going to matter a lot. Is it clear?
Yes, sir.
Right. So remember, the ingredients proportion is needed, or we need to maintain that to get the tasty cookies. Imagine you are adding too much of sugar. So we will not able to get the tasty cookies, right? It will be too sweet in the taste. Now,
Yes.
right. Okay, good. Now let's consider one scenario that in which we don't have 2 eggs, we have only 1 egg. So is it possible to get 10 cookies with the 1 egg?
No, sir.
No, obviously no. So for the 1 egg, we need to reduce the proportion of other ingredients also. And your answer is correct. Good. So if we have only 1 egg, we need to reduce the proportion of the ingredients 1, 2, and 3. That is flour, butter, and the sugar. So instead of 10, we will get only the 5 cookies now. So what is the important thing? Important thing is that the proportion of ingredient is going to give us the desired product. And here the stoichiometry comes into the picture. So stoichiometry tells us the quantity of reactant we need to get the desired product. Aditi, read this for me.
Okay, sir. Stoichiometry tells us what quantity of each reactant we need in order to get enough desired product.
Right. So which quantity we are focusing? We are focusing on the quantity of reactant and then the product. So if we are considering the reactant quantity and the product quantity, so we are trying to get the stoichiometry or the proportion. Right? Understood this?
Yes, sir.
Okay, very good. Now let's focus on how this stoichiometry is going to help us in the chemistry. So as I mentioned, stoichiometry gives us the quantitative relation between the amount of reactant used and the amount of product. Then on what it is based? It is based on the law of conservation of mass. And we know the law of conservation of mass, right? So in the law of conservation of mass of the reactant should be equal to the mass of the product. Okay, let's take one example so that it will be more clear. So let's consider the example of burning of a carbon plus oxygen, which is going to give us a carbon dioxide, right? So if I mention here that I have a 12 gram of carbon and 32 gram of oxygen. So Aditi, tell me how much reactant I have? If carbon is 12, oxygen is 32. How much reactant we have?
44 gram of
Reactant.
CO2.
Yes, very
Yes.
good. So if I have a 44 gram of reactant, then absolutely correct. We should get the 44 gram of product. Good, correct answer. And that's what we are trying to learn here. Amount of reactant and amount of product. Relation between that is nothing but the stoichiometry. Understood this?
Yes, sir.
Okay, very good. Now the next point. So let's try to focus more by considering one balanced chemical equation. So we are focusing on the water formation reaction. So here two reactants are present. What is the name of this reactant?
Hydrogen.
It's okay, very good. It's a hydrogen molecule. So I will consider this as a gas. So you might be asking, sir, what is the state of this gas? And then this is a liquid. So this is the oxygen. And in the product side, I'm going to get the water. First thing you will check whether the chemical equation is balanced or not. So what do you think? Is this equation balanced?
Yes, sir. Balanced equation.
Yes, yes, it's a balance equation. Very good. Now, let's try to understand what info we are getting from this balance equation. Or what does this chemical equation represent? So here, if you observe, the 2 moles of hydrogen are reacting with the 1 mole of oxygen. How many moles are here? Here we have a 2 moles of hydrogen which are reacting with the 1 mole of oxygen. And then we are going to get the 2 moles of water. So Aditi, if you observe carefully, focus on the coefficients. Coefficient 1. So here nothing is mentioned, means it should be 1 here, right? Here it's a 2. So these coefficients are representing the number of moles. So you are getting this point? How many hydrogen moles I have? I have a 2 moles of hydrogen. How many moles of oxygen? 1 mole of oxygen. Yes. And then we are going to get the 2 moles of water. This is very important. Why it's important? Because every balanced chemical equation is going to give us a mole ratio. Okay? So every balanced chemical equation is going to give us a mole ratio. So I have explained this. 2 moles of hydrogen. For every 2 moles of hydrogen, we need a 1 mole of oxygen. So if you take the ratio, so if I ask you hydrogen to oxygen, what is a mole ratio? So what will be your answer? Hydrogen to oxygen mole ratio, number of moles of, very good, 2:1. One more question. Help me with the mole ratio of hydrogen to water.
2:2.
2:2.
2.
2. Very good. Right. 2:2. And it's a very simple, right? So if you consider the mole ratio, it is nothing but the moles of the two substance ratio, right? So number of moles of substance 1 divided by number of moles of substance 2.
Yes.
Yes. And one more important thing you are going to remember, that always consider the balance chemical equation, right?
Yes.
Okay, good. So let's check if you understood or not. So I'm going to ask you one simple question. So here one reaction is given. 4 iron, 4 Fe reacting with the 3 oxygen molecules. We are going to get the iron oxide. Fe2O3 is nothing but the iron third oxide. Now the question number 1 for you. What is the mole ratio of iron to iron third oxide? Fe2, Fe2O3. And what is the hint for you? Hint. Focus on the coefficient. Go ahead, Aditi.
4 is to 2, sir.
Very good. Correct answer. 4 is to 2. Absolutely correct. Question number 2. What is the mole ratio? Mole ratio between iron third oxide and the oxygen gas. So in the numerator, we have Fe2O3. In the denominator, we have oxygen. Go ahead.
Yeah. 2 is to 3.
2 is to 3 is the correct answer. Okay. So this is the mole ratio. But remember, when you are going to take the mole ratio, once the reaction is balanced, right?
Yes.
Okay, very good. So you understood it clearly. Okay, the next. Now the stoichiometry we understood. Stoichiometry is going to tell us the amount of reactant and the amount of product in a balanced chemical equation. It gives us a relation. Now, there might be possibility that the reactant or the product will be in the different units or it will be expressed differently. So we have to focus on the 3 important conversions. One is mole to mole, another one is mole to mass or mass to mass. Now you might be thinking why we need to have so many conversions. As I mentioned, we can
Yes.
express it in the mole also, we can express it in the mass also, right? So there are different ways. That's the reason we need to, just a minute, Aditi. Okay. So Aditi, we were discussing regarding the stoichiometric convergence. Fine.
Yes, sir.
Okay. So as I mentioned, there will be more than one ways for expressing this. Either we can express it as a mole, either we can express it as a mass. Okay, good. So let's try to focus on the first one, that is mole to mole conversion. So we will consider one example. Then I am going to explain how this mole ratio is going to help us for mole to mole conversion. So focus on this problem. So we have a calcium carbonate which is reacting with the 2 moles of hydrogen chloride. Now you are familiar with the coefficient. So I'm directly using the 2 moles. So here how many moles of calcium carbonate? 1, right? Which are reacting with the 2 moles of HCl. So in the product side, what we are going to get? We are going to get calcium chloride, water, and the CO2. Now, what is asked? How many moles of CO2 can be produced when 4.5 moles of HCl react in the above reaction? So, Aditi, when the question is given, always focus on the given data, right? Solution. So, what is given? 4.5 moles of HCl are reacting, right? So in a one line, we will try to get the answer for this question. So always focus on what is given. given. What is given? 4.5 moles of HCl, right?
Yes, sir.
Okay. So I will just, first we will try to write down what is given and then we will get the answer. Second thing. What is the mole ratio? Mole ratio. So what is asked, whichever parameter is asked, consider the mole ratio for that only. So we are interested in the two parameters. One is the HCl, another one is the CO2, right? Focus in the question. They have asked us how many moles of CO2 when 4.5 moles of HCl are given, right? So we are not bothering about the other reactant or product. We are only focusing on the HCl and the CO2. You are getting this point?
Yes, sir.
Okay. Now the hint for you. Always take the unknown quantity in the numerator or the asked quantity. Now here they have asked us CO2. So you are going to consider the mole ratio. While writing the mole ratio, consider CO2 in the numerator. So it should be 1 mole of CO2 to the 2 mole of HCl. Why I did this, Aditi? Because it is asked how many moles of CO2, right? That's the reason I took it in the numerator. And denominator, I took the 2 mole of HCl. Okay,
Yes.
good. Now let's try to write down our answer. So number of CO2 moles is equal to how many moles of HCl are given? Write down 4.5 moles of HCl multiplied by mole ratio. Mole ratio is 1 mole of CO2 divided by 2 mole of HCl. And I hope you are getting, Aditi, what is asked, you have to take in the numerator. So here, this mole of HCl gets cancelled, right? So,
Yes, sir.
right, in the answer, what we will get? 4.5 divided by 2. So near about how much it will come? 2.1, 2.2. How much it's going to come? 2.25, right?
Yes, sir.
Mole of CO2. Aditi, just cross check the answer. I'm giving you some time so that you can cross check the answer.
Yes, sir. It is right.
Okay, very good. So using the mole ratio, we have calculated the moles of CO2 produced. So you understood this?
Yes, sir.
Good. Okay. Okay, perfect. So what we have done, I'm going to give you the hint also. So three important steps you have to remember. First, always begin with a balanced chemical equation. Always cross check whether a chemical equation is balanced. Identify what is given and what is asked. So in the when you are going to write down the mole ratio, always numerator should be unknown, denominator should be known. Right? Whenever you are going to write down the mole ratio, what is the hint I am giving you? Always write down the unknown or need to determine, or what is asked. And in denominator, what you are going to do? What is known? Known or given. So this is the hint for you. So you want to try one example? Aditi, you want to try one example? You are there, Aditi? Hello. Yeah, I'm able to hear you. So you want to try one example?
Yes, sir.
Okay. So I will give you one example, okay? So just try this example. Wait a minute. Good, you are catching fast, Aditi. I'm going to ask you one simple example. Okay, let's focus on this question. Sodium metal burns in air according to the balance equation. They have given us the equation. 4 sodium reacts with the oxygen. We are going to get twice of sodium oxide. Now, what is asked? How many moles of oxygen are needed to completely react with 9.5 gram of sodium? So, as I mentioned, always start with what is known. So, what I'm going to write down here, Aditi, I will write down here 9.5. Right? The first thing you are going to do is converting this mass to the moles. Mass to the moles. Because I am using here conversion ratio as a 1 mole of sodium and in denominator molar mass of sodium. And can I check with you? Do you know what is the molar mass of sodium? You know, it will be 23. So what I'm going to write down here, Aditi, I am going to write down here 23. Now, again, focus here. I'm highlighting some important info. So moles of oxygen are asked. That's the reason I am taking it in the numerator. Right? I am taking it in the numerator. And what is known? This is mole of Na. You are getting this, Aditi?
Yes, sir.
Okay, good. So here 1 mole, but how many moles of sodium? Mole ratio you are going to write down. Just a minute. Oxygen 1 mole and sodium is given as the 4 mole. Okay. So Aditi, can you calculate this? Just take some time and calculate it. So it should be around 0.1032 mole of oxygen. Okay, Aditi?
Yes, sir.
Okay, good. Very good. So what is the important thing that you need to focus? So first, always consider the given data. What is given? In this problem, you got like 9.5 gram of sodium was given. Now, since it is given in the gram, so we have converted this to the mole. Then the next step we have done, that is convert to mole. And then it becomes very easy. Third thing is the use mole ratio. Mole ratio and get the desired answer. Okay, Aditi?
Okay, sir.
Okay, good. One more simple problem I'm going to give you. Let's check. Okay, Aditi. So read the question.
A reaction between potassium and water produces hydrogen gas and potassium hydroxide. How many moles of hydrogen are produced if 0.0400 moles of potassium are used?
Okay. So what will be our first step is writing the balance equation, right? The step one will be the balance equation. Good. Okay. So this is the balance equation. So 2 potassium are reacting with the 2 moles of water. We are going to get 2 KOH plus H2. Now, Aditi, as I mentioned, always highlight what is given, what is asked. So what is asked? Moles of hydrogen. So I am highlighting this. This is need to be determined. So we will take it in the numerator, right? Need to be determined. What is given? 0.4 moles of potassium. So this is given. So how you are going to start? What is given? They have given us a 0.04 moles of potassium. K I will write down. Multiplied by. Now, Aditi, I need to take the mole ratio. So what mole ratio I will take? Hydrogen should be numerator or potassium should be numerator?
Potassium.
Potassium. What needs to be determined? Hydrogen or potassium?
Potassium, sir.
Read it again, Aditi.
Moles of hydrogen.
Ah, yes. So what should be in the numerator then?
Hydrogen.
Hydrogen. Now you got it, right? So 1 mole of hydrogen. So what needs to be determined should be in the numerator. 1 mole of hydrogen. And what is given? 0.04 mole of potassium. Now it becomes very easy. Cancel, cancel. Right? Wait. I made a mistake here. Not 0.04, the ratio. In hurry, I wrote wrongly. It should be 2, right? So what should be your answer? It should be 0.02 moles of hydrogen. Got it?
Yes, sir.
Okay. So what you need to remember that what is asked should be in the numerator and what is given should be in the denominator. Okay? Okay. Okay, good, Aditi. So we will end up session here. So thank you for choosing eTutor World. If any doubts, let me know.
Okay, sir.
Okay. Okay. So we will continue those in the next session and go through the practice sheet which I have shared with you.
Okay, sir.
Okay. Thank you. Bye bye.